Let's consider solve problem 3 on asymptotic analysis. And here's your problem. What is the time complexity of the following program? The program is available in front of you. You need to determine the time complexity. It is better if you can pause the video for a while and try to answer this question on your own. I hope you're done. Okay, let's move on to the solution. Here you can see again, this statement is going to take a constant amount of time. There's no loop, there's no multiple executions, just a single statement. Here you can see I have declared variable I and variable j. This declaration is going to take a constant amount of time. After that, we have a for loop, which is an interesting for loop, right? We have this I equal to 1. We are running this up to n by 3. And obviously the increment is by one step. So you can clearly say that in the iteration number 1, I is equal to 1. In the iteration number 2, I will be 2 because we are incrementing by one step. Therefore, in the iteration number 2, I will become 2. In the iteration number 3, I will become 3. In the iteration number 4, I will be 4 and so on. If you run this up to iteration number k, then I can say that I is equal to n by 3, which is equal to k, because in the last iteration, I is equal to n by 3. We are assuming that we are running up to k iterations. That's why I is equal to n by 3 is equal to k. As k is equals to n by 3, as we are running this loop n by 3 times, I can take the upper bound on it, which is n. So big O of n is the time complexity. But let me tell you that I have taken the upper bound on it, right? Why I'm not taking n by 3? I'm taking the upper bound. I'm just eliminating the constants and simplifying this and writing this over here n. So it is clear that this loop runs n times, right? Now let's consider the another for loop. Here this loop is running from 1 to n, but you can see over here the increment is by 4 steps, not by a single step, right? So let's consider the iterations. In the iteration number 1, j is equal to 1. In the iteration number 2, j will be 1 plus 4 because the increment is by 4 steps, right? So you need to add 4 to this. This is 1 plus 4. In the iteration number 3, this will be 1 plus 4 plus 4, which is equal to 1 plus 2 into 4. I can write this 1 plus 4 plus 4 as 1 plus 2 into 4. There is a reason behind this, why I'm writing, I will tell you later. In the iteration number 4, this will be 1 plus 3 into 4. Similarly, in the iteration number k, this will be 1 plus k minus 1 into 4. Now you can clearly see why I have written 2 into 4 over here and 3 into 4 over here, right? Because in the iteration number 3, this is 2. In the iteration number 4, this is 3. Similarly, in the iteration number 2, this is 1. And iteration number 1, there's nothing over here. So it is clear that in the iteration number k, this will be 1 plus k minus 1 into 4. And this is equal to n, right? Because in the last iteration, we have n over here. So 1 plus k minus 1 into 4 is equal to n. Let's solve this. I can bring this 1 over here. This becomes n minus 1. After that, I can bring this 4 in the denominator and this becomes n minus 1 divided by 4. Again, I will bring this 1 over here. This becomes n minus 1 divided by 4 plus 1, which is equal to k, right? So basically, this loop is running n minus 1 divided by 4 plus 1 times. I can take the upper bound on it, which is big O of n. Now you can clearly see how many times this printf function has been evaluated. We have evaluated these two for loops. This for loop is running n times. This for loop is also running n times. So the total time complexity in this case is big O of n square. Isn't that so? Again, we are choosing the upper bounds. This is very important. You should take the upper bounds, not the exact times. Here obviously this loop is running n by 3 times, but we have taken the upper bound, right? The upper bound is n. So what we are assuming that this loop is running n times. And we are also assuming that this loop is running n times. Because this is a nested for loop structure, the total time will be big O of n square. So this is the time complexity of this particular code. Okay friends, this is it for now. Thank you for watching this presentation.